Today we are going to see Shannon Fano code. This is vanilla. Now we are going to see how a Shannon Fano code can be constructed and how to find the code efficiency and redundancy. The five source symbols of the alphabet of a discrete memoryless source and their probabilities are S0, S1, S2, S3, S4 and its probability is 0.4, 0.19, 0.16, 0.15, 0.1. Design Shannon Fano code for the given source. Determine the average code length, coding efficiency and redundancy. So here finding the Shannon Fano code is going to be the procedure is different, but finding average code length and coding efficiency and redundancy is same as that of your Huffman code. So here they have given 5 codes. So first step in Shannon Fano code is write the probability in decreasing order or descending order and write its corresponding source. So already the probabilities are in decreasing order. So I have written this one along with the source. Before start doing the problem, I have to check whether the sum of the probability is 1. So here the sum of the probability is 1. So the first step is the probability should be divided into two parts, equiprobable. So if it is 1 now, so the sum of the probability is 1. So equiprobable is, it should be of either 0.5 and 0.5. So this is going to be the equiprobable. But here the first step itself is going to be 0.6, so zero point 0.4 probability. So here the first one can be divided into 0.4 and 0.6. You can go for the second option. So this is nearer to your 0.5 and 0.5. So this is 0.4 and 0.6. So we can include the second one and find the next possibility. So if I just include this one, it's going to be 0.59 and then 0.31. So this is more or less, this both are more or less equal here. If it is so, if this condition occurs, which one is we are going to choose? So in this one, we have to choose the probability which is going to have the lesser one. So this is 0.4 and 0.6. So as the number of code words should be minimum for the high probable for Shannon Fano code. So we are going to choose 0.4 and 0.6. So I'm just going to divide it. So the first step is to divide it into 2. So I'm going to divide this as 0.4 and then 0.6. So after dividing it into 2, I'm going to give 0 to your upper part and then 1 to the lower part. So again this is over, only one is there, so we'll finish it off this one. And here you have 4 probability. This should be divided into equiprobable as 2. So here the equiprobable, here the first is over here. So now we'll see the second combination. So here the first one is the remaining left out probability is going to be 0.6. So equiprobable means it should be divided by as 0.3 and 0.3. So that is going to be the equiprobable. So here, so 0.6 can be divided into 0.3 and 0.3. But here, if you're going to take the first one, it's going to be 0.19. So 0.19 and then the next is going to be 0.41. So this is so much deviations you have. So let us try the next one. So if I'm going to add these two, it's 0.19, 0.16. So it's going to be 0.35. So it's going to be either 0.35 and 0.25. So you have two different combinations here. Here is 0.19, 0.4, the deviation is more for 0.3, 0.3, but 0.35 and 0.25, the deviation is very less. So we are going to choose this part. So you are going to, the step 2 is, so I'm going to divide this as 0.35 and 0.25. So 0.35 and 0.25. So the upper part I'm going to give as 0, the lower part is going to be 1. So here step 3 is I have to do this steps until I have only one value for each and every subdivision. So here I have 2 now. So I don't have any other option. So I have to divide it as a single part. So it's going to be 1, sorry, upper part is 0, lower part is 1. And here also I have only 2 probability. So I don't have any other choice or calculation. I can go for this one. So if you have more than 2 probabilities, only we will have to go for this calculations as equiprobable 50%, 50%. So here if you have only 2 probabilities, we are going to divide it into 2. That's it. So now we can calculate, we can form the code words here. So the code word for point 4 is going to be 0. Code word for 0.19. So this is source and probability. Point 4 is it's going to be 0. So from step 1 you just calculate it. So it's 0. So it's 0. And for 0.19 it's going to be 1 0 0. And for 0.16 it's going to be 1 0 1. And for 0.15 it's going to be 1 1 0. And for 0.1 it's going to be 1 1 1. So each and every code word is of unique, and then which is going to have the highest probability. The number of code words is going to be, the number of bit is going to be 1. That is going to be the minimum. So the code length is 13333. So now after forming this Shannon Fano code, we'll go for the average code length. The formula is same, summation k equal to 1 to k, pk, nk, and then pk probability into the code word, length of the code word. So 2.2 bits per symbol. Then code efficiency formula is HR, that is your entropy divided by average code length. We know the average code length. So have to find the entropy. The formula is summation k equal to 1 to k, pk, log base 2 of 1 by pk. So probability 0.4 into log base 2 0.1 by 1 divided by 0.4. So likewise we have the 5 probabilities. So just type that in your calculator, you'll be able to get only your log base 10. So we'll be using that same one. So if we want to get your log base 2 of a means, so we are going to divide log base 10 of a and then log divided by log base 10 of 2. So I'm going to find the log base 10 of a throughout, and then the whole thing I'm going to divide it by log base 10. Log base 10 of 2. So I type as such what I'm saying now, 0.4 into log 0.4 inverse plus 0.19 into log 0.19 inverse plus 0.16 into log 0.16 inverse plus 0.15 into log 0.15 inverse plus zero point 0.1 into log zero point 0.1 inverse equal to, you will get your number that divided by log 2. So it will be getting 2.149 bits per symbol. So the efficiency is 2.149 divided by 0.22, so 2.2, which is nothing but 0.977, that is 97.7 percentage. So code redundancy is 1 minus efficiency, it's going to be 0.023. Thank you guys. Have a nice day. Subscribe my channel for automatic update.